For 9.2, we are going to be working with slope, doing it in the easiest way, which is just by counting off of the graph. We will do it together. I will show you how it is done. When we're talking about, for example, hills, and it was really, really steep, would you say that it has a steep slope? Right? The slope is really steep. That is what slope is on a graph as well. We have a definition. Slope is the rate of change of a line, which means how steep is the line. Is it super, super steep? Is it not that steep? That's what we're looking at with slope. Okay? We do have a formula. All right. Slope is always represented by the variable, or not the variable, the letter M. I do not know why it's not S. It's just M. Always has been, always will be. Okay, so whenever you see M, anytime in math, whether you're in pre-algebra or whether you are in calculus, slope is always going to be M, no matter what.
Or slow?
Slope.
Oh, I thought you said
slope.
Slow.
Okay, so calculating slope has a specific formula. We call it rise over run. Rise over run.
Wait, so it's supposed to say rise?
So let's think about it. Remember how when we were talking about coordinates yesterday? And you have to go into the elevator before you can go up? Yep. Okay, so think about it. When I say slope is rise over run, is rise going to be the y values or the x values?
Y.
The y's, because they go up and down, right?
Yep.
And so run means?
Sideways.
Sideways, or x's. So slope is actually opposite of when we graph a point. For slope, we count the y's first, and then we count the x's. Rise over run is a way for us to remember that. Okay? So how do you find the slope? There are 4 steps for us to finding the slope from a graph. Okay? On the graph, you will be given, you need to first pick 2 points. Okay? And you can pick any 2 points you want. You can pick the first point and the last point, the first point and the second point. It does not matter which points you pick. You will get the same slope every single time, and we're going to show an example of that. Okay? So, after we pick our 2 points, step 2, we count the number of units. If we're looking at rise, that means we're counting either the number of units up or down from the first point to the second point. So we're counting the rise first, the y values. Step 3, after we hit to that y point, we need to count the number of units over, right or left. From the first point to the second point. Question, if I'm going up, does that mean my number should be positive or negative? Positive. If I'm counting down, it should be negative. What if I'm counting to the right? Is that positive or negative?
Positive.
Positive. And to the left is? Negative. Very good. Okay?
Positive.
And then after we do all of our counting, step 4 is we're going to write the slope as a fraction, rise over run.
Again?
Okay? So we put the y values on top, and we put the x value on bottom. Okay? Okay, so for the example 1, which is the only example, I give you a line, and it has 4 points. And what I want us to do during this time, we are going to be finding the slope between these certain points. Okay? So the first thing that I'm going to do on this is I'm just going to set up my fraction for each one, m equals, and a fraction bar. So that way all I have to do is fill it in. So we're counting the slope.
Wait, I can't see.
Okay, we're counting the slope on here.
I know.
Okay, so guys, the first slope that we want to find is the slope between points B and C. So we start at B. C is right here. We need to count how many spaces up do I go to get from B to C. How many spaces up is that? 1, 2, right? So that's my rise. So I put 2 on top of the fraction.
Oh, wow.
Okay, now staying at that point, I count how many spaces over. 1, 2, 3, right?
Okay.
So my run is positive 3, and that goes on bottom. So what is the slope between B and C? 2 over 3.
Oh, B.
Okay? Kind of makes sense? Let's try part B together. The slope between A and B. So I'm starting at A, and I count the rise first. So how many spaces is that? 1, 2, right?
Yep.
So 2 is the rise. That goes on top. Staying at that spot, what's the run? 1, 2, 3. So what's the slope between A and B?
2 over 3.
2 over 3 again. That's kind of weird. It's the same.
Wow, it's like...
So I want you all right now, find the slope between points A and D. Does anybody have a guess what it might
6
be?
over 9.
A guess. Don't do it yet.
Oh, I already did it.
Who has a guess?
6 over 9.
Nope.
What?
Kevin, what do you think your guess is? If between these two is 2 over 3, and between these two is 2 over 3, what do you think the whole thing is going to be?
It's 4, 6.
I think it's going to be 2 over 3. Try it.
Whatever, Michael. Whatever.
Okay, so let's do it. If I start at A, how many spaces up do I go to get to D?
6.
1, 2, 3, 4, 5, 6.
Teamwork.
So the top is 6.
Good.
How many spaces over?
9.
9? 2, 3, 4, 5, 6, 7, 8, 9. Okay, 6 over 9. So I'm done, right?
Nope. No.
No. Does that fraction reduce?
Yes. 2 over 3.
What goes into both 6 and 9?
3.
3. 3 goes into 6? 2 times. And 3 goes into 9? 3 times. So my slope was still 2 over 3. Okay, really quickly.
Wait, is that what the homework's going to basically be?
Yep. Okay. Slope of a line is consistent throughout the whole thing. So I can pick any 2 points on any line, and I will always get the exact same slope every single time. For this one, 2 over 3. Every line has a different steepness, but I could have even picked B and D, and you would still get 2 over 3. I could pick C and D, and you would still get 2 over 3. Okay? So I could pick any point on this line, and the slope would always be 2 over 3. Okay?